Hello, we are the MoleBots from the Colorado School of Mines. We are presenting the following designs for acceptance into the 2017 Drillbotics Competition, as we have already received full funding to build this rig as a senior design project. We also have an advantage as we can use parts from the rig constructed by our team last year. The frame is shown here with detachable wheels and detachable sliding rails to make transportation through doors and around campus easy. The biggest change from last year's design is the hoisting system. Instead of using pneumatic pistons or even hydraulics, we have decided to use a drawwork system to raise and lower the traveling block as well as control weight on bit. We have designed the system with a stepper motor geared to a spool. As the stepper motor rotates very small steps at a time, we will be able to increase and decrease slack in the cable to control how much weight is on the bit. We have also included a power off brake to stop rotation if power is lost or not on. The cable from the spool extends over two pulleys and is connected to a tensile load cell on the exterior of the traveling block. This connection will raise and lower the traveling block along the sliding rails. The traveling block will include the top drive motor connected in line with two precisely mounted bearings. Between these bearings will be a torque transducer, a rotary union for fluid to enter the drill string, and a Hall effect sensor. Below the final bearing will be a platform containing a wireless transmitter. This wireless transmitter will have wires connected to it that travel down the drill string to the BHA. BHA will act as both a stabilizer and the location of a downhole 9-axis IMU sensor. It will be a steel cylinder 1 inch in diameter with tungsten carbide inserts placed evenly around the circumference to maintain contact with the borehole walls. The top of the cylinder will be precisely milled with a 1/8 inch end mill to create slots for the sensor to be placed and then covered. Finally, we have a fluid system similar to that used by the team last year, using mineral oil as the drilling fluid. It contains a collection system, pump, and piping to remove solids and enter back into the drill string.
Our control software will use LabVIEW and run on the NI C-RIO control platform, which allows us to gather and display the data. Our user interface will have typical time and depth-based plots, a visualization of the optimization process, a wellbore diagram showing formation changes, and a manual control panel. The wellbore diagram will help visualize different sections and events over the course of drilling by color-coded intervals based on the optimal settings and resulting rate of penetration, vibrations, and other parameters averaged over the span of the interval. Our control software will work as follows. After drilling a pilot hole, the rig will then start a drill-off test. It uses an optimization algorithm to find the fastest and best drilling parameters. We will be using the downhill simplex algorithm. The objective function will be primarily determined by rate of penetration, but also take into account downhole vibration and mechanical specific energy to increase hole quality and reduce wear. The mechanical specific energy and vibration need to be minimized, so they are subtracted in this equation. The weight of each component will be set based off of experimentation. We chose to use the downhill simplex algorithm because it can continue to converge in a dynamic space, and it uses a heuristic to greatly reduce the number of search points, reducing the time spent drilling at each operating parameter. This optimization process is visualized in real time on our display. We are also considering adding additional features to help the user quickly understand the status of the drilling operation and assist in post-well analysis. We will derive useful information from this enormous stream of data and summarize it so that a passive user can understand key events and trends. We will also extract critical information and present it in a narrative form that can be understood by anyone, regardless of technical competency. We are also considering using audio indicators to convey essential information without requiring the driller's full attention. Thank you for listening.